Hi class, this is Neil, and this is the final video of lesson 1 of unit 9. And in this portion of the video, which really starts on page 4 of your handout, we're going to look at finding a missing angle. Before we do that, I'm going to give you some notes on what are called the inverse trig functions. So I'm going to move over to my slideshow. All right, so inverse trig functions. So they're used to undo sine, cosine, and tangent, and what they allow us to do is solve for a missing angle. Inverse sine is written like sine to the power of -1 of whatever the angle is. Sometimes you'll see it written as arcsine. Inverse cosine is cosine to the -1. Sometimes you'll see that written as arc cosine. And inverse tangent, or tangent -1, sometimes you'll see that written as arctan. So again, these are used to help us find missing angles, to undo the ratio so that we know what the angle is. All right, so we're going to take a look at an example problem, and then I'm going to give you some hints with the practice problems that you have to work through. Okay, so let's go back to our worksheet. All right, so in the example, we're finding a missing angle. So in triangle HEY, the measure of angle Y is 90, EY is 33, and I also know that HE is 62. And we're asked to find what is the measure of angle H to the nearest degree. So I'm just going to underline everything that's important in that problem. So the angle I'm interested in here is angle H, but we don't know what that angle is. So I'm going to write X next to that. I know that the side length, EY, is 33. And I also know that the side length of HE is 62. Now, I'm going to turn back to the acronym that we've looked at before. I'm going to show you another way that a lot of people like to write that acronym because it helps us a little bit better see how we need to write those ratios. So remember, the acronym is SOHCAHTOA. So another way I can write that is SO. Sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And toa, or tangent, is opposite over adjacent. So notice in the way that I wrote it this time, you automatically can kind of see how those ratios or how those fractions need to be written. Okay, so turning back to our triangle then. Our angle is angle X. I'm going to draw an arrow to the opposite side to label the opposite side. I'm going to look at my right angle and draw a line from that right angle to the side opposite it. That's the hypotenuse, on my longest side. And now the side that's left here is adjacent. Okay, so I like to circle or highlight the things I know about this triangle. So I know the hypotenuse is 62. I know that the opposite side is 33. So these are the two sides I have information about. That tells me that I'm going to be using the sine ratio. All right, so let me write my equation. So remember, it's always sine of some angle. So sine of X here is equal to, now if we need to see the ratio again, I'll just write opposite over hypotenuse. But we can actually just fill in that opposite hypotenuse with the information I know. So sine of X equals 33 over 62. Okay, so to solve this now, or to undo the sine, what I'm going to do is take the inverse of sine. So remember, that's that sine of -1. So I'm going to do that to both sides. Sine of -1 here. Sine -1 on this side. So on the left side of the equation, that's going to cancel out my sine. And on the right side, I'm going to have x equals sine to the -1 of 33 over 62. All right, so I'm going to really just now turn to my calculator because I can't do anything else here on my own. I'm going to go into Desmos, and you find those inverse sine functions in the function menu. Let's delete what we already have. So we're finding sine -1 of 33 divided by 62. And we see that our angle here is 32.15. And it keeps going, but because we're just asked to find it to the nearest degree, so the angle again is 32.15. To the nearest degree would just be 32 degrees. All right, so x equals 32 degrees. All right, so that's how we use inverse sine functions. Okay, so for your examples, you're going to need to do the same. Label the triangles, decide which ratio you're looking for, and use that inverse ratio to help you find the angle. Now, 1 and 2 are pretty straightforward. Again, you do in question 2, you're going to need to label your triangle. The angle that's specified is angle T. In question 3, it takes a little bit of interpretation. And in fact, maybe we should set up that problem together. So a communications company is building an antenna to carry cell phone transmissions, as shown below. Determine to the nearest degree the angle that the antenna makes with the wire. Okay, so here's my antenna, and here's my wire. The angle that I'm interested in is this angle here. All right, question 4, which you're also going to be asked to do. Remember, you have to think back to question 4 on the previous problem set. We're not told any side lengths here, but we're given a specified angle, angle C, and we're given an x value and a y value. So one of those values is going to tell us our horizontal distance of that triangle. The horizontal distance is this distance. And the other coordinate is going to tell us our vertical distance. For part B, which you're also asked to do, you're asked to determine the length of a radius of circle C. You actually are not going to need any type of trig ratio to solve that. Our radius, remember, in this instance is going to be the same as our hypotenuse of our triangle. All right, so think about what formula we use to find a missing side length of a right triangle. Okay, if you want to look at the challenge problem, that will be extra credit. But that's the end of this lesson. All right, have a happy time doing the math.